Another 2 minutes, we'll start. I have updated the attendance. You can look into it in your SAP. I hope. Few students are quite absent. Maintain one. Like if 253 roll number is absent gradually, he is last class absent. This 637 and 758. This 1493. These are the main absence. Okay, so now it is 4. Are you able to see the screen?
Yes, sir.
Yes.
So already 50 students. Okay. Let's start. So to go a little faster. So last class we studied that is 2 kinds of operating system. One is the serial operating system, and one is the batch operating system. The most of them are working in the same fashion, the user has to be give the jobs, and the job has to be executed in a one after another. Means at a time only one job will be executed. You cannot keep more than one job inside the memory. But the basic difference between the serial and this batch is that in case of serial, the jobs, the OAT is submitted in the same sequence it is going to be executed. Whereas in case of batch operating system, the similar kind of jobs has to be bring together and make a batch, and the whole jobs, all the jobs belongs to a single batch will be executed at a time. And in both the cases, you can find the user interaction is not possible. Means during the execution of the program, if any error comes or anything is required, that cannot be, user could not interact at that moment. Rather, once the program execution gets over, whenever your deadline has given by the operator, that operator will just provide that as this is the error or this is the output. This you have find out. And since the number of jobs has to be in a single batch, has to be go one after another, the automatic sequencing of those jobs will be done by one program called as what? Anybody? The automatic
resident monitor.
That is the resident monitor. Then we studied that even if the resident monitor will be improves the utilization of the CPU, still there is one more factor involved while executing the program is the speed of the IO devices as compared to the speed of the processor. Since the speed of the processor is quite high as compared to the IO devices, so because of this difference, the CPU is most of the time idle. So to avoid this idle time of the CPU, we utilize a buffer. So the buffer may be a single buffer, maybe a double buffer, maybe a multiple buffer, which is called as a circular buffer. And if still your CPU is too faster as compared to few IO devices like card readers and printers, in those cases, they are introducing a new buffering concept called as spooling. And this spooling is basically called as a simultaneous peripheral operation online. Means at the same time, multiple peripherals are executed at the same time. Means if you can, these are the peripherals. Basically, the IO parts are the peripherals. This is card reader. These are the peripherals. At a time, they are executing it. Even if the CPU is executing some job, at the same time, some data is reading from the card reader and stored in a buffer that is called as the spooled buffer. And that spooled buffer basically created in the hard disk. And simultaneously, the data will be read from the card reader. At the same time, the CPU is executing the program by reading from the memory. And at the same time, the jobs whose output has already produced but not yet entered into the printer for printing purpose, those things are placed inside the spooled buffer, and from that spooled buffer the printer is accessing. Means this job, and this job, these three jobs are done simultaneously. That's why I say wherever the spooling is used, there you can say that the multi-programming is supported. Multi-programming somehow supported. Programming is supported. And another interesting part you can find out, last class I told at the very end, what is the difference between the spooling versus buffering? Yes, spooling versus buffering. So what this spooling basically says, it handles the IO of one job with the computation of another job. What does it mean? The meaning is that when one job's this data will be transferred from card reader to this for further execution, the CPU may be executed, other programs job is currently executed by this. And this job, whichever is currently executing and whichever is currently fetching, the two jobs may be completely different. But as for the buffering is saying, both IO of one job, IO and computation, you can indirectly say the IO and computation belongs to the same job. Yes. Now, one question somebody may ask or raise in your mind, sir, how is it possible this CPU can able to do something and at the same time this card reader is able to store the data, or the data gets fetched from the card reader and stored in hard disk? Do you think that without the involvement of the CPU, this can be done? That something will be read from this card reader, a dump kind of this hardware, and read it and directly put it here? It is usually not possible, because any reading or write operation, the CPU is usually involved. But how the CPU is doing somebody's job, but at the same time it is possible. So this feature or the hardware that enables the spooling is called as the DMA. The hardware that enables the spooling called DMA. So DMA means This is called as a direct memory access. I'll just give a overall view of what is this. You will study these things in the COA as well as the last topic, IO management item. Direct memory access. What basically happens in case of direct memory access? Let's take this is IO devices, and this is my CPU. What the CPU wants to do? The CPU wants to transfer some data from somewhere. So he is executing and wants to transfer. So this is my memory. Yes, and the transfer has to be takes place in between this. Then what happens here? The CPU try to involve, say that I'll do this operation. But while doing this operation, the CPU is not doing any work. Rather, he is most of the time he is becoming ideal because this work is currently going on. Rather than doing this, what he is doing, every IO has an IO controller. We have studied. Yes, this IO controller has a processor. What the CPU has done, the CPU has assigned this job to this processor, that you please transfer this data in between your IO and the memory. The moment you complete this work, you please inform me once. Are you ready, my mind? Instead of the CPU is completely involved in this transfer between this IO devices and the memory, the CPU instruct to this IO controller that you transfer this kind of data from IO devices to this memory or from this memory to this IO devices. Once this completion over, you please inform me or interrupt me. So that once you inform to this IO controller to do this job, then the CPU is busy with some other work. And at the same time, this IO controller processor are able to do these things, the transfer between the IO and memory without the involvement of the actual CPU. So that is basically called as the direct memory access. Means this IO devices directly accessing the memory without the involvement of the CPU. The CPU has involved, he has instruct what to do, but once he has instructed, the contractor is doing all these things. Once the contractor do all these things, then you will inform to the officer that it is done. Rather than the engineer will be directly involved here to transfer this data, the engineer told to the contractor that you please do these things. Once this work gets over, you please inform. So that's why with the help of the DMA, this pooling is basically possible. If the DMA is not there, you can directly say, sir, these things cannot be done at the same time. Correct or not? Are you getting my point? So three things basically involved here. The multiple reading, writing, executing of three different jobs can be done simultaneously. And another important feature, and this simultaneous work can be done only because these devices are support this DMA technique. If the DMA technique is not available, the general spooling is not possible. Okay, so that is the idea. And please ask.
Sir, the size of the spooling is defined during installation of the OS, or it is just just we can change it.
That actually, if you can internally go to the operating system can able to change the spool buffer size. Any buffer size can be changed through the OS.
So means that it is in some other partition or what? In the hardware, in the hard drive?
It is usually in the different partition of the hard drive. That's always. Like a swap is there, no? I'll tell you, there is a swap is there. Similarly, a spool buffer can be maintained separately.
Okay, sir.
So this is what it is. So according to this two operating system, one thing we have observed that both the operating system like batch and serial are executing only one job at a time. Multiple jobs cannot be done. Means if a job requires some CPU, some IO, then some CPU, then some IO. What does it mean? Means when you write a program, you are doing some A equal to B plus C. This is a computation statement. Somebody can write after that printf. This is a IO statement. Somebody can find a square root of 30. This is again computation statement. Somebody can write down the B equal to 10 plus C. This is a computation statement. again you are making a scanf. This is a IO statement. Means your whole program is a combination of some computation, some IO, some computation, some IO. So when it is involved, if it is a program one, if you can consider a program one, though as the batch and serial both are executing one job at a time, during this execution the CPU is busy, but while he is required for this printf or any IO kind of statement, the CPU is completely ideal. Again the CPU is busy and again the CPU is ideal. Then what happens? Whenever there is a IO operation takes place inside my job, that time the CPU is completely ideal. Then what's the better way? The better is that if you can keep more than one jobs at a time, P1, P2, P3 at a time, then what happens here? While the P1 is executing its CPU oriented job, the CPU is executed in the P1. The moment this job needs one IO, the CPU can involve with this P2's CPU oriented jobs. Are you getting my point? What I told? Instead of keeping only one program, if multiple programs are currently placed inside the memory, while the current program's IO requirement comes, where the CPU does not involve, rather the CPU is going to be ideal, instead of avoiding this ideal situation of the CPU, he can execute this P2's CPU job. The moment again its IO started, if that time his IO is over, it's okay. Otherwise, we can go for one more processes, this CPU oriented jobs. Then what happens here? In this scenario, the three jobs are simultaneously executing. It may not be parallelly, but it is simultaneously executing. Yes. So this kind of technique is called as a multi-programming operating system. Multi-programming OS. If there is any flaw, you please tell me, because the operating system has a design depending upon the requirement, and gradually some flaws will be there in the existing. That's why they have developed the new one. So that way you have to understand, so that आपको रटना नहीं पड़ेगा. You just understand that first this come, then must be this, like this. So what happens in case of a multi-programming operating system? More than one job placed inside the memory at a single time. Yes, but in the previously only one job was present in the memory. Since more than one jobs will be placed, then what is going to happen here? So if every job, if you can say the job is a combination of CPU oriented and IO oriented. CPU related work plus IO related work. Yes, and when the one job is executing its CPU related job, then he is executing. The moment he needs one IO related job, that time only the CPU moves from one job to another. Means the switching of the CPU. Switching of the CPU from one job to another job happens at what time? Can you tell me? Happens at which scenario? One scenario is what? The job gets over. Current job gets over. Current job is completed in one case, or second case is if the current job needs any IO. Agreed or not? So in this two basic scenario, it has to come here. Then what is the advantage? The advantage is that the utilization of the CPU is better.
Sir, and also an interrupt also.
That I am not focusing a lot. Okay, that because interrupt when it is occur, the interrupt basically occur when there is any IO kind of things are required. Basically, yes or no? Yes. Because why you can say that, sir? Why the software interrupt will not occur. The software interrupt, if it is occur, who will create the software interrupt? The process which is currently executing. Yes or no?
Yes,
The
sir.
process which is currently executing, that process only create a software interrupt jobs. So that's why I'm saying if there is any IO interrupt comes, then IO related things comes into picture. I don't specify specifically an interrupt that occur. And the advantage of this is that the utilization of the
Sir, here if the interaction is allowed.
user interaction is allowed. User interaction is allowed. Very nice. The user interaction is allowed. Yes. Any problem in this? Please find out. हम थोड़ा स्लो जाएंगे लेकिन आपसे एक्सट्रैक्ट करना चाहता हूँ कुछ प्रॉब्लम हो पाएगा इस टाइप का जॉब में सपोज 5 जॉब पार्ट टाइम आया है सपोज आई क्लिक ऑन द
Sir, priority.
Huh?
Which job to give the next is the problem.
what again
Sir, which job to give is the problem.
that is not it
When the IO occurs.
no
Under the priority.
no that is always is there any kind of operating system you bring any sophisticated operating system if there is a n processes are there currently present if one process is executing now among n minus 1 process which has to be selected that is based on certain criteria that cannot be avoided at any scenario okay but one problem here it is he said unless until his IO requires another process cannot start yes or no suppose a single process is currently executing he needs more IO more CPU oriented job. Suppose you have started a WordPad and at the same time you have started the VLC player. Can you tell me what happens in this scenario? Suppose इसको क्लिक करके तुरंत इसको क्लिक कर दिए क्या होगा बोलिए मल्टी प्रोग्रामिंग ऑपरेटिंग सिस्टम में
Sir,
कोई
तो
बोलिए
नहीं होगा।
नहीं नहीं
मतलब ये होगा VLC चलेगा
नहीं
IO
मैं
interrupt में रहेगा ना word file
सपोज ये पहले से शुरू
First WordPad will be the build.
started can your VLC will be immediately started or it will not shown
हाँ,
सोचिए what
immediately नहीं होगा
हाँ
immediately नहीं होगा पहले word खुला है हमें
ये कब होगा
Sometime.
जब इसका if it is a 10 second required then after 10 seconds the VLC screen will be open do you like this or you want the more I click on the WordPad and after that immediately I double click on the VLC what we want that both has to actually start yes or no so what happens here the response time is not faster response time is not faster क्यों नहीं होगा बोलिए why the response time is not response time means मैं चिल्लाया मतलब suppose मैं पूछ रहा हूँ hey ex student are you there if you are quickly response means response is faster if after 5 minutes you are saying sir present then it is response is slower now you tell me here is this the response time is really faster or slower and if it is faster why if it is slower why somebody can answer other
it is slower because because if we start that word file first it will take some time to start it and then IO device will IO input will be means IO entered will occur so sir when the IO entered occurs then only VLC will start because then only the process freeze.
Very nice Deepak. Are you getting others please so what he has told unless until my CPU work of this program gets over or IO if IO not IO gets started this next program is not going to be run by the CPU because the CPU switching is only happened when the current job's IO is coming otherwise it is not means if my current job is mostly CPU bounded then the response time for the other jobs will be quite high but if the current job is IO bounded what is IO bounded what is a CPU bounded IO bounded job and CPU bounded job. Guess what is the CPU bounded job and IO bounded job? In case of IO bounded job, most of the works written inside the program are IO related, and in a CPU bounded job, most of the work written inside the program are the CPU related. Means in some programs I don't write more printf and scanf, only computation like this. But in some cases I need more input output, ज़्यादा display कर रहा हूँ, ज़्यादा scanf लिखा हूँ. In that case it is a IO oriented jobs. If it is a IO oriented jobs, it may be faster. Why? Because I know that very little CPU is working, then again IO comes. A long IO, again a little CPU, again a long IO. Means in this scenario, my VLC will be quickly start, because the current job which is executed by the CPU needs a little CPU rather than a more IO. But if your current job is more CPU bounded, then obviously my VLC player will not start very quickly. Yes, so that's why the response type somehow it is delayed in this scenario. But the advantage is that more than one program runs simultaneously. Do you think that your current operating system is using this or not?
No, sir.
No, because in the current operating system, although it is multi-programming, still they are saying the response time of the current operating system is quite fast. Because at a time
multitasking.
it is multitasking or something, but it is quite fast. And what is that? That operating system is basically comes, the next one is called the time sharing operating system. Yes. So in this time sharing operating system, a quantum time is fixed. What is this quantum time? Suppose the quantum time is 10 milliseconds. Means every job will be get a chance to execute it for 10 milliseconds first. After the 10 millisecond, suppose this is my job 1, this is my job 2, this is my job 3, like this. So is requires some CPU. So even if you requires here CPU, this is my CPU required and this is my IO required. Even if my CPU required is 30 millisecond, but after exactly 10 millisecond, this is my 10 millisecond, the CPU has to be switched to the next job. Are you getting my point? What this quantum time says? Depending upon my quantum time, after the quantum time gets over, the CPU has to be switched from the current job to the next job. Means after this quantum time, the CPU jumps from current job another job. What happens here? Like I told, a barber case. So in the barber case, how it is executing? Suppose he is a person 1, this is a person 2, this is a person 3, this is a person 4. Suppose each person's hair cutting requires a 30 minutes. Okay, 30 minutes. And this requires also 30 minutes. This is a small boy which requires 15 minutes. And this is an old man, this requires some 20 minutes. And these two are very young, they want very nice hair cutting, require 20 minutes. What the barber has done, the barber has placed a quantum time QT is equal to 5 seconds. Then how it will be executed? Can anybody tell me? When this job is going to be completed at what time? What time this P3 is going to be completed? Exactly, calculate.
3. No.
Tell me.
First P1, then P2, then P3. So
No.
5.
No, because it requires 15 minutes of time.
होगा.
Then tell me.
55 seconds.
55 seconds, somebody is told?
55 seconds.
55? Yes, correct. Why? Because first 5, first 5, first 5, first 5. Again 5, again 5, again 5, again 5. Then again 5, again 5, again 5.
55.
How much? So this is become 55. Means after 55 seconds, this P3 is going to be completed. Like this, what it doing? After every 5 millisecond or 5 seconds, the CPU jumps from one process to the another process. Means how the response time is improved here? The response time is improved because if 4 jobs are at a time started, means come at the same time, then this P4 job, which is click at the 4th time, because you cannot click 4 jobs at a time. I have to make a mouse click very fast. First P1, P2, P3, P4. But this P4 will be guaranteed started after how much time? 15 seconds or not? Guaranteed or not? Why? Because this job will be executed for 5 minutes of time, then this job, and after that guaranteed he is going to be started, because our time sharing operating system says that based on this quantum time, my CPU has to be moved from one process to the another process in a rotated manner. Okay, so that is the reason here the response time has improved. Response time has improved. Is it more interactive or less interactive? Is it more interactive or less interactive? This is more
responsive.
This is more interactive jobs. Yes. Can you tell me in the multi-programming case and this time sharing case, where the waiting time will be more? Means the people has to wait for a lot of time.
Multi-programming.
टाइम शेयरिंग में वेटिंग टाइम बढ़ जाएगा? कैसे बढ़ेगा बोलिए तो कोई एक एग्जांपल दीजिए कोई.
Sir, if the process is at the very last, then it will take more time to get there.
Okay, one process. I'm saying by one process's waiting time, do you think that the whole system's average waiting time will be increases? You think about the whole system. If a whole system was
only for that process.
Only for that process. What about other processes? Do you think that other processes waiting time will not increase?
Sir, what process waiting time will be increased because the time is dividing, right? Because
just see, suppose this process, this 4 persons comes to the barber shop, and barber is cutting little bit here, little bit like this. He is rotating and cutting their hairs. In this particular case, all these 4 persons almost completed at the end or not? पूरा लास्ट को जो छोटा सा मतलब हेयर बच जाएगा, सबका लास्ट को कट करेगा. Then only the 4 persons hair cutting gets over or not? Means all persons are waiting till end. Means all the persons are waiting for a longer period of time, even if they have come at the beginning or not. But what about my multi-programming? In the multi-programming, it may not happen in all scenario, because in case of multi-programming, if my job is really requires only CPU oriented jobs, then what the CPU has to do? The CPU starts here, complete it, then come out. Is he waiting for a long time? Not at all. Why? Because as per this rule, once the CPU starts its job, he will be continued till one IO comes. If there is no IO is there, then obviously he will be completed, then another process gets started. Here the response time is reduced, the waiting time may be less, but as for this time sharing, the waiting time will be gradually increasing. क्योंकि आप बहुत fair करना चाहते हैं मतलब everybody has to be go in the same fashion. Means at the end only everybody is going to finish. So that's why in this scenario the response time is high. But our operating system mostly based on this one, and we will gradually see when we learn different kinds of scheduling algorithm perform in case of time sharing, then we'll see how the waiting time is also reduced. But one observation you can find out, since my CPU, as somebody has already told, since my CPU is partially doing each job in a rotation manner, that's why at the end every job will be completed. So if at the end every job will be completed, my response time will be quite high. So waiting time will be quite high. Let's see what is the waiting time. Just a minute. If P1 P2, P3, P4 starts at all comes at a 0 time. Okay, and he wants 8 unit, 8 unit, 8 unit, 8 unit, and your QT is 2 units. Can you tell me what is the waiting time for him? What is the waiting time for him? What is the waiting time? What is the waiting time? Let's you think what you are thinking waiting time. मैं थोड़ा जानना चाहता हूँ. Before waiting time, before waiting time. Can you tell me quantum time कितना है? 2 यूनिट. अभी बोल पाओगे कि एक कब कंप्लीट होगा, एक कब कंप्लीट होगा, एक कब कंप्लीट होगा, एक कब कंप्लीट होगा, बोल पाओगे सब लोग?
सर हर एक का 24 यूनिट्स वेटिंग टाइम होगा.
नहीं, पूरा सही तरह से बोलिए. सपोज P1, P2 पूरा सोच के बोलिएगा. P1
24, फिर 26, 28.
इज इट 24 में खत्म होगा? कोई बोल रहे हैं 24 में. इज इट करेक्ट?
फर्स्ट वाला
26
तो
एक कब खत्म होगा बोलिए? When this work is going to be finished?
So 26.
26.
Why just see 6 unit, 6 unit, 6 unit, 6 unit completed. Then it's 2 unit which is become 8 unit. Yes or no? Because it's got 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 6 हो गया. Then it's got 2. Means total 6, 6, 6, 6, 6, 4 in 24. 24 plus 2 is comes as a 26. Correct or not? Accepted? Then he will be 28. He will be
30.
He will be 32. Now can you tell me how much time he has waited? Just think. सोच के बोलिए कितना टाइम ये रुका होगा. सपोज आप गए हैं कोई एक दुकान के पास, आप बोले कि मुझे 8 घंटा का काम करना है, लेकिन आपको 26 घंटा तक ड्यूटी है. कितना घंटा आप वेट किए यहाँ पर? 6 minus 8. Very nice. It is 18. This is 20. This is 22. And this is 24. So these are the waiting time of these 4 processes or not? Yes or no? Correct or not? Yes. So if you can look into it, now the total waiting time comes as a this 40, 40, this 40, 40, 40, 80, 84. So 84 by 4 comes as a 21. Average waiting time आपका आ गया 21 units. हुआ कि नहीं? बहुत सारे. Suppose सोच लीजिए same thing if you can do it using a multi-programming. Yes, multi-programming. And इसका काम क्या क्या आ रहा है थोड़ा देखते हैं तो आप समझ जाओगे. The same thing you have to do in a multi-programming. And in a multi-programming, think that my job is fully requires CPU. This job also fully requires CPU. This job also fully requires CPU. And this job also fully requires CPU. Yes? Can you tell me what is the waiting time in this scenario? Suppose सब लोग 0 unit, 0 unit, 0 unit.
First one will be 0.
0. Very nice. Because शुरू हुआ तो खत्म हुआ. Then 8. Then 16. Then 24. अगर मिलाएंगे करीब करीब कितना आ रहा है 40, 48. And 48 by 4 comes as only 12 units. ये कम हो रहा है कि नहीं? Are you getting or not? Yes. If you apply these things in a multi-programming, then normal multi-programming, then here the waiting time is reduced. The average waiting time comes only 12. But in this case, the average waiting time comes as 21. बोलिए.
Sir, suppose in multi-OS, multi-processing OS, and infinite loop runs.
Infinite loop runs. Oh, okay. In multi-programming or in this time sharing?
Multi-programming, sir.
If in a multi-programming, if an infinite loops runs and it never ends, you can say that this is not going to start up. Yes or no? In this idea. In a multi-programming system, if an infinite loop is running and that loop does not require any kind of IO operation, then definitely, as per his view, this code will never start. Correct or not? Accepted?
Yes.
Yes, understood. Now you understood what is the time sharing, which is a very important one we have studied. Now the next few operating system will quickly go, which we may not use currently, but later in the higher studies, if you can go, it will be useful. The next one is coming, the network operating system. And one more is also there, that is a distributed operating system. I'll give you an idea of what is this network operating system. Basically, the network operating system says that the multiple computers or the systems, here I'm writing computers, network together to share the resources. What does it mean? The meaning is that if you can think of, suppose it is our department. In this department, in one room, this computer, this is one computer, this is one, this is one, this is one. And they are connected in some way. They are connected. Okay, they are connected like this. Now what happens? This has a printer. And this had some other printer or scanner. Then what is the benefit of this? Even if, suppose I am sitting here in my room, even if in my computer there is no connection of a printer and scanner, but I can able to print my data through this printer or scan my data through this scanner. Yes or no? Why? Because since the resources which is required for my computer, even if it is not available physically with my computer, but in the network it is available. Since in the network is available, I'll give a command. By this command, my data is going to be printed here. So that after gets printed, I will physically go there, collect my print page. Are you getting the requirement of this? Because the most important requirement of the network operating system is that where the resources are shared among many computers, in that case, those computers has to be connected in a network so that any user can able to access these resources even if has physically not directly connected to that resource. In the distributed case, the same thing is going to be exactly happening. Yes, like I'll tell you a small example of this. Let's take you are sitting in this and your Google account is present here. Means the Google is maintaining a server where your data is stored here. And the moment you open this Google account and tell that I want my Gmail, actually your Gmail's data is coming from this to this. Yes, and you think of it is a resource which you are accessing it here. If the resource is accessing it here, this is also based on a kind of network. But why it is called as a distributed, why it is called as a network? The most important thing is that in case of network operating system, if a user is going to access any resources, he has to know the location of the resources. In this case, the user should know the location of the resource. Yes, what does it mean? Means I know that this resource is present in 19.2.7.35 computer. This is my IP address. Yes. So if this computer's IP address is this, means this resource is present in this machine, he knows. Then how will connect? He has to establish a remote login. Yes. By making a remote login, then he can able to fetch this data. Means in normal network operating system, one knows about where exactly the resource is present. To access the resources, one has to make a login and access it. But in case of distributed operating system, the resources are completely transparent to the user. Resources are completely transparent to the user. What does it mean? Means when I'm putting a Gmail account, I make a login, but that login, is it a location or that login is a verified or authentication? When we are logging with our user ID and password, is it a login with the particular machine or you are just authenticating yourself that I am a valid user? Usually you authenticate.
The
But have you,
authentication.
yes, have you ever specified that where my Google account's data is present? Never. Means the resources, the Google account are completely transparent to me. Means where it is present, I just know that. That's why the distributed system and network system varies in this way. In one case, I know the exact location where it is present, I connect it and access it. But in this case, I don't know. My operating system is able to manage these things. Since he does not know where exactly it is present, in most of the cases, the resources are redundant in nature. Resources are redundant. What is the reason behind this? Because since it is distributed, my work gets distributed or my resource gets distributed, and where it is not present, the same resources may be available here. The reason, if this is going down, I don't know where it is present, but at least the same data, if it is present here, I can able to fetch it. And please remember, your data, your Google or Yahoo or somebody is most of the time keeping in a redundant manner. In one server, in another server also same data will be present. If this server could not be able to connect at that moment, then another server will connect and fetch the data. But for me, from where it is coming, I don't have any idea. So that makes you distributed. But in case of a network, I explicitly know where it is present, I connect it, then I fetch this. Got it? Is it? Really?
Sir, but indirectly we are specifying that location, where we are when we are specifying the www.google.com, then we are specifying that address, 8.8.8.
I basically understood. That fine, very nice. When you are giving this, you anyhow you have to do it indirectly. कोई तो किसी को तो एक पता होगा ना, एक resources है, हमको छुपाया जा रहा है. Do you think that nobody knows? If nobody knows, how we can fetch it? ठीक है नहीं? आपका question पूरा valid है. Because for a user point of view, it is transparent. It is not like that for the whole system. It is transparent. Whole system transparent होगा तो किसी का डाटा किसी को आ जाएगा. है कि नहीं?
Yes.
I know that my Google account store in the XYZ server. If X में नहीं मिला तो Y में मिलेगा. If Y में नहीं मिला तो Z में मिलेगा. So that makes. But I don't know where it is. But here I explicitly know. कुछ किस टाइप का कनेक्शन यहाँ एस्टैब्लिश करते हो, कभी यूज किया हो? अभी तो आप घर में हो.
SSH.
हाँ, कभी कभी SSH यूज करते हो, कभी कभी FTP यूज करते हो, कभी कभी टेलनेट यूज करते हैं. हम लोग टेलनेट में, FTP में, SSH में, जब आप हॉस्टल आ जाओगे कभी, then from one room to the another room, if you want to transfer any data, if your internet is not working, this may be one of those. Yes or no? Because your network is there, but internet is not there. So since the internet is not there, means I can able to ping from this machine to this machine to know that as this machine is currently active. If I have a telnet server present here, I can log into this telnet server and fetch all the files whatever present here. Okay, that's that. That is called as network operating.
Sir,
Then
means that operating system knows that address,
operating system always knows here also, both the cases. But here, when you want to access a resources, user has to know the address. User ऐसे connect करेगा, FTP ऐसे करके करेगा, FTP abc@19.2.7.35, फिर मांगेगा पासवर्ड दीजिए PWD, फिर मैं पासवर्ड दूंगा, then मेरा prompt आ जाएगा. And this prompt is not your prompt, rather this machine's prompt. If you put ls, it will show you all the files present in this machine in your computer. Got my point? Yes, that's all. Then next operating system is called as a multi-processor operating system. Multi-processing OS. So what is the difference between multi-programming and multi-processing? In this case, more than one processors are present. More than one processors are present. Yes, processors. But they are what in multi-programming? That's mean more than one program. Means can you say that every multi-programming will be a multi-processing, or every multi-processing will be a multi-programming? समझ पा रहे हो? प्रोसेसर मतलब क्या है? सीपीयू बोल रहा हूँ, सीपीयू। एक कंप्यूटर में, जैसे लास्ट क्लास है शायद मैं दिखाया कि मेरा कंप्यूटर में सोच लीजिए 8 कोर्स है, 8 सीपीयू है। Yes, and my Ubuntu OS is able to manage with the 8 CPUs. Manage मतलब this CPU can distribute, this OS can able to distribute its job among the 8 CPUs at a time. मतलब 8 jobs are done parallelly. You can think of this. But if I have one more machine which has only one CPU, but my Ubuntu OS can also run it here. This Ubuntu OS is supporting what? Multi-programming. There are n number of programs are running. P1, P2, P3 programs are running. But can you run 8 programs at a time, or only one program at a time running? Once it comes out, next program, like this it is doing. But one by one it is running. Even if it is time sharing also, 2 minutes of this, 2 minutes of this, 2 minutes of this running in one CPU. But here I have multiple CPUs. If I have multiple CPUs, then OS has to be capable enough to handle it. Why the OS involved here? You can say, sir, उसमें तो 8 प्रोसेसर है। OS यहाँ पर ऑपरेटिंग सिस्टम का रोल कहाँ से आया? कैसे आया? देखिए, suppose I have you have now 8 GB with some Pentium Core i5 processor or i7 processor. So it has 8 cores or 16 cores are there. Let's take, I install a Windows 95 operating system. Windows 95 बहुत पुराना operating system. Even if I put a Windows 95, if I put a Windows 95 operating system here, even if I have 8 cores, but if I have 10 programs, but it will send only one program to one CPU, other CPUs are completely ideal. Why? Because my operating system does not know how to manage its programs among more than one processor. That's why even if my hardware supports more processor, but my operating system does not support it. So that's why this multi-processing operating system plays an important role. And your Ubuntu, all these new operating systems are supporting multi-processing operating system. Means they can able to handle more than one CPUs at a time. And this multi-processing operating system basically of 2 types. One is called as the shared memory, multi-processing OS, and another one is called as the distributed memory, multi-processing OS. So what happens in this case? In case of shared memory multi-processing, if this is the CPU 1, this is the CPU 2, like this, we have a CPU, n CPU, and all these processors are using a single memory. Single memory means any data they want to transfer or any communication they have to done, they have to go through a single RAM or single memory, you can think. But in case of distributed one, every processor are the independent memory. Yes, then what is the advantage of this and this? The advantage is this: the communication among this processor are very fast. Yes or no? Because they have a common memory. If he wants to send something, he will put it here and he will drag from here. But in this case, since every processor has their independent memory, the communication cannot be directly takes place. So the operating system involved here to do something. And what is the advantage of this kind and why they are used this? Here they are saying if a common memory is used, then there is a need of synchronization. जैसे बोला था ना, एक सिंक्रोनाइजेशन का एग्जांपल दिया था, शायद याद है ना? Because if 5 persons are using a same place, then 5 persons has to be synchronized with each other. Otherwise, पूरा मारपीट हो जाएगा. But here, since they are separated, there is no question of synchronization involved. So that comes the multiprocessing. And last operating system is called as the real-time OS. Yes, what this real-time OS says that in case of real-time OS, the jobs are basically time-bounded. Jobs are time-bounded. What does it mean? The time-bounded means every job fixed with a certain deadline. Every job fixed with certain deadline. What is the example? The example is you can say that flight operation. Yes, when you are going through flight, so whatever the system there in the cockpit, you can directly say the whole thing is a real-time operating system. What's the reason? Every job is time-bounded. What does it mean? Means the moment you click on the button for landing, at within 2 seconds or within 5 seconds, whatever the time they have given, this wheels has to be come out. If the wheels does not come out within this, you have to be sure that you are not in the safe side. Yes or no? Yes, because every job there means every program executed in that system are time bounded. The moment I click, I know that it has to open immediately. If it is not opening, the system is going to be crash. That's why it is called as a real time. At that time, it has to do it. If it is not, then it is going to crash. So that's why it is called as a real time operating system. Okay, so there is a like you can say a satellite launching or missiles launching. So missile launching क्या है? नॉब को प्रेस कर दिए 9 10 9 8 7 6 5 4 3 1 फिर नहीं गया फिर आप गए. If it is not come out, then वहां पर जो होंगे वो चले गए क्योंकि वहां पर ही ब्रस्ट हो जाए. So that's the reason this operating system are time bounded and every job has to be completed before its deadline. But again, this real-time operating system is divided into 3 types. One is called the hard RTOS. One is called the farm RTOS. And another one is called the soft RTOS. Yes, what is hard RTOS? They are saying if the deadline is not met, if the deadline is not met, then the system is going to crash. Yes, means after that you cannot use this system. So the examples are like missiles launching and this flight systems are basically comes as a hardware. Means उसमें पूरा ऐसे डिजाइन हुआ होगा कि any job will come out if the deadline is X, before X it has to be completed. एक भी मिनट उधर उधर गया. That's why this type of operating system is so sensitive. Okay. Then farm real-time system. What is saying? I'll give you an example. Then you can say that what is farm real-time system. The last minute I'll complete. The farm real-time system says that like video conferencing. You know that in the video conferencing that usually the video and the audio both has to become. But the video size is a little more size as compared to the audio. So कभी-कभी क्या होता है ना वीडियो नहीं आएगा तुरंत लेकिन ऑडियो आपको आ जाएगा. And after 2 seconds or 5 seconds or 10 seconds, that video will come. But do you need that video at that time? Because the audio is different. Then we don't require that video. So in that scenario, the deadline is there. What is the deadline for this? Whenever the audio comes, the video has to come at that time. But if the video does not come, means that video has no huge. But the system is not going to crash. Means what is saying? If the deadline is not met, if the deadline is not met, then the result has no use. Then the result has no use. But the system is not going to crash. The system will not fail. Why? Because later we can do this. Even if sometimes in the TV or any communication it happens. Later sometime the video comes which you don't like. Okay, so this is called as a video conference. Yes. The last one is soft activities. The soft activities is basically, we give an example of the web browsing. Web browsing में क्या होता है बोलिए? Suppose I open a page, open a page and I wait, a page आ रहा है. अगर 1 मिनट पूरा हो गया, बंद कर दीजिए वो पेज और एक साइड खोल लीजिए. आप तुरंत इरिटेट होके बोल दे रहे हो कि नहीं? Means what happens? As the output, as the result of the output go beyond the deadline, the importance of the output gradually goes down. मतलब 2 मिनट तक ठीक है, 3 मिनट तक ठीक है. अगर 5 मिनट तक वही पेज नहीं आ रहा है, then I will say that it is no use, better to start another. So that is called soft real-time system. Means he's saying as the execution time progressed, beyond the deadline, the importance of the result gets degraded. The importance of the results gradually degraded. Yes, because here what happens? It will wait. As it will cross 5 minutes or something, up to 5 minutes it has some importance, but after 5 minutes it has no use. लेकिन डेडलाइन मेरा 1 पे था, मैं 6 मिनट तक वेट कर रहा हूँ. 1 पे खत्म होने वाला था, लेकिन 6 मिनट तक मेरा दिमाग में है, ठीक है हो जाएगा 6 मिनट तक तो ठीक है, बट 6 मिनट के बाद और मैं टॉलरेट नहीं कर पाऊँ. I have to cross. But in this case, moment it will cross 1, I will not use that output. I will do something else, but my system will not cross. And in this hard real-time system, after 1 minute, if my deadline is 1, after 1 minute, I cannot use that system. System to crash कर जाएगा. कुछ नहीं. That's it. Okay, that's all. Sorry, I took up to 4 minutes. Now I can go.
सर सर वर्चुअल बॉक्स को हम लोग क्या कंसिडर कर सकते हैं?
अभी आऊंगा वर्चुअल बॉक्स को, अभी आऊंगा स्ट्रक्चर ऑफ ऑपरेटिंग सिस्टम में आएगा. नेक्स्ट टॉपिक.
सर वो तो डुअल ऑपरेटिंग सिस्टम कोई मतलब विंडोज और उबंटू को दोनों को एक साथ.
वो टाइप नहीं है. वो टाइप क्यों नहीं है बोलिए तो? क्योंकि आप वर्चुअल बॉक्स के ऊपर एक ऑपरेटिंग सिस्टम चला दो कि नहीं? कैन यू ऑपरेटिंग सिस्टम इज चेंजिंग?
नो.
So that's why it is not a type of operating system. It is a structure of operating system. Structure मतलब क्या है? एक ऑपरेटिंग सिस्टम के ऊपर आप बहुत सारा ऑपरेटिंग सिस्टम इंस्टॉल कर पाते हैं ना. सो हम नेक्स्ट क्लास में पढ़ेंगे. देयर आर 4 लेयर स्ट्रक्चर ऑपरेटिंग सिस्टम, कर्नल स्ट्रक्चर, माइक्रो कर्नल स्ट्रक्चर ऑपरेटिंग सिस्टम, ओनली कर्नल स्ट्रक्चर ऑपरेटिंग सिस्टम एंड VM स्ट्रक्चर ऑपरेटिंग सिस्टम. ओके, वो 4 टाइप का कल पढ़ेंगे. ठीक है ना?
ऐसा कोई लिमिटेशन है कि इतना OS इंस्टॉल कर सकते हैं हम लोग?
ऐसा कुछ लिमिटेशन नहीं है. लिमिटेशन बस डिपेंड करता है कि आपका जो बहुत ज्यादा हो जाएगा तो ऑब्वियसली स्लोअर थोड़ा हो जाएगा कि नहीं. अगर एट ए टाइम में 10 ऑपरेटिंग सिस्टम VM में चलाऊंगा, स्लो होगा कि नहीं?
यस सर.
क्यों स्लो होगा आप बोलिए? क्यों स्लो होगा?
क्योंकि CPU डिवाइड होते जाएगा.
तो कैसे भी वो डिवाइड होगा, CPU भी डिवाइड होगा, मेमोरी भी आपका डिवाइड होगा. क्योंकि आपका रैम जो है, रैम तो बढ़ नहीं जाएगा. रैम जितना 8 GB को 8 GB है. अभी अगर 2 ऑपरेटिंग सिस्टम लोड हुआ था और 4 GB करके इंटरनली वो डिस्ट्रीब्यूट कर रहा था, अगर अभी 10 हो जाएगा, सम MB में या KB में आएगा. MB में KB में अगर एक ऑपरेटिंग सिस्टम को चलाओगे, स्लो तो लगेगा ना. ठीक है नहीं? करेक्ट पॉइंट. वो स्ट्रक्चर में पढ़ेंगे। फिर जाएंगे कंप्यूटर कैसे स्टार्ट करते हैं, फिर हम शुरू करेंगे प्रोसेस मैनेजमेंट। सो कल का क्लास थोड़ा प्रोसेस मैनेजमेंट भी शुरू होने वाला है। सो बी रेडी, डोंट मिस द टुमारोज क्लास।
थैंक यू सर।
समझ में आ रहा है? थोड़ा सीक्वेंस पूरा फ्लो आ रहा है? सीक्वेंस अगर मिस हो रहा है आप बोलिएगा, हाँ, नहीं तो मजा नहीं आएगा पढ़ने का।
Yes, sir.
Yes, sir. Thank you, sir.
थैंक यू वेरी मच। आई एम एंडिंग।
Thank you, sir.